Hey, it's Szymanski here with the physics clan of knowledge takers, and we're going to talk about race cars. Why? Because they go in circles, and we're doing the unit called circular motion. So I figured, let's put two and two together and get 8. I'm sure that works out mathematically. You double check my work. So first thing we've got, fundamentally, we've got a race car here making a turn that has a radius of 130 meters. The race car takes this turn with a speed of 25 meters per second. What's the coefficient of friction? Seriously? This teacher is making me do Muse again? Oh, this is horrible. Required to allow the race car to take this turn. Oh man, it's like I'm not allowed to forget anything in this class. So if we look at a circle, so I've got my race car in a circle. Now I'm not saying it's doing a full donut here, it's just carving out part of a circle. So look at my race car. Oh, look at that, it's an awesome race car. So center of my circle, let's say it's over here. It's accelerating towards the center, and the force that makes it go to the center is, anyone? Force that makes race cars go in circles instead of straight line? Friction, that's right. Without friction. I mean, centripetal, that's a close. Yeah, okay. Studio audience is only doing so far. So good. All right, so we're going to be looking at friction, because without friction, cars go in straight lines. It's kind of a thing. Newton, worked on that. So if you look at this, to do friction, we have to have normal force. And the normal force is supported by the ground, so it's coming out of the page at me. I can't draw that very well. So this is what we often refer to as kind of drawing a flat circle, or looking just in the x-plane. So I'm going to redraw my car. Oh, look at those art skills. That's a car. Oh man, so awesome car. And friction is pulling me, I'm going to say to the right. I mean, I could have said to the left, but that means we're going to play with negatives. I hate negatives. They're so, let's just use the word negative. So other forces involved are normal force pushing me up by the ground, and gravity hating me as always. Yay, it hates me. So I could have drawn this going to the left, but, whatever makes you happy. Like I said, I like working in positives. One thing we want to keep track of is we will still be accelerating to the right. So if I had drawn this to the left when I do net force equations, I would have had negative acceleration, but then negative friction. It would have canceled out, so it doesn't really matter. All right, so let's start doing some physics here. If I make my list of my givens, the radius was 130 meters for this curved section. We're going at a speed of 25 meters per second, and that's it. Oh, this could suck. Okay, have no fear. We try anyways. So we have our net force equation, and so sum of the forces in the center of the circle equals MAC. The force that's in the center of the circle, friction. That's friction there, because our circle's going this way. That's why we make our drawings. So we really have friction here. And then mass, I'm going to replace centripetal acceleration with v squared over r, because that's the information we were given. All right, okay, I don't know friction, I don't know mass, and I don't know mu yet. Okay, this sucks. All right, well, let's see. Hold on. I know stuff. Friction, we had an equation for that. Friction equals mu times the normal force. All right, so I can do that replacement into here. So I can have mu times the normal force equals m times v squared over r. So now I don't know mu, I don't know the normal, I don't know, oh boy, okay, wait, hold, deep breaths. Okay, balanced forces. Yes, balanced forces. So normal force is equal to mg. I can do that replacement there. So I have mu mg equals mv squared over r. And oh my goodness, do you see what I see? Mass cancels out. How awesome is that? I know, it's like, I know. Everyone's jaw just went like, what? Mass cancels out sometimes? Yes, it does. All right. So have no fear. Just keep going until stuff starts to make sense. If it doesn't make sense, just keep going anyways, because, we ask that. All right. So now we're going to solve for mu here, because we now know 9.8 is our gravitational field strength. The velocity was 25. Don't forget to square it. People forget to square that a lot. And then the radius was 130. So if we want to figure out what's the actual coefficient these tires must at least have, solve for mu. You get 0.49. So that's the absolute minimum coefficient of friction that must be there to make them go in a circle instead of a straight line, because if that coefficient of friction is any less, that car ain't making that turn. Although I guess you could slow down too. But hey, it's racing. So as we like to say in the gaming industry, play more games.